Hey guys, my name is Mal, and this is a follow-up video for how to build a Kubernetes cluster with Raspberry Pis. On the first video, I showed you the implementation of this practice, but I didn't actually explain why I did it. Now we can look up to the why we created Raspberry Pi Kubernetes cluster with K3S on Alpine Linux. Before that, I need to talk about my motivation. It was to build my own self-hosted environment, because I did not want it to be dependent on the big companies like Google and Microsoft. And first thing I've done was to look into the home server solutions like on this picture. I've had to think about the hardware cost. It is not exactly cheap to build a home server. You need at least a server, a switch, a cooling fan, and couple cables. And every time you need something to add, you'll go deeper. You'll say I need storage, so I need to get a NAS server solution. Then you'll say I want to expand my wireless area, so I need to buy an access point device. And for the energy, you need a PoE switch. That means power over Ethernet. The list goes and goes. And every time you add a new device, you need to think about the power consumption, the noise it makes, and of course the cost. You'll start with a couple hundreds of dollars, but you'll end up spending thousands and more. That is why I chose Raspberry Pi. It is cheap, consumes no power considering the other solutions for home servers, and it takes really a small space. With the last Raspberry Pi version 4B, you can have gigabit Ethernet connection. Micro HDMI supported with 4K display, but I'm gonna use them for service, not for desktop, so I won't need the HDMI ports actually, just for the first boot for installations. And we have also USB 3 ports. You can buy SSD and connect it to the Pis to get really high I/O speed. So now we have the hardware, but we still need to think about the software. First, the operating system. Raspberry Pi have an official operating system called Raspberry Pi OS, and also there is a Debian version for the Pi called Raspbian. And there are so other Linux distributions have an ARM image package that we can install on our Raspberry Pis. But as you can see in the picture, Alpine Linux has the smallest image size. It is mainly used for containers in Kubernetes or other virtualization environments. It is secure by design. Because of the image size and tools that has contained inside, it has a small attack surface. And because of that, it is really fast and using almost no system memory. After I first installed Alpine Linux on a Raspberry Pi, I've seen the memory usage was like 40 megabytes, and for an ARM device, this is a perfect choice if it's enough for your needs. After the operating system, we need to think about the software that we can run for our applications. Traditional method is just installing them onto the operating system, but if we have to run multiple applications in the same environment, installing them on the same operating system is not applicable for neither performance nor security and for many other reasons too. That is why container technology is used so much in today's production environments. For the managing multiple containers, we have so many options, but one of the most used today is Kubernetes. With Kubernetes, you can create multiple applications with so many features like built-in DNS server or load balancer. It provides a better management through modularity. Containers allow applications to be decomposed into smaller parts with clear separation of concern. But probably the best feature in Kubernetes is its scalability. You can scale any application containers as much as you need, and you don't need to install the same environment for multiple servers. If your infrastructure is not enough, you can just add another node to the cluster and scale your application with just changing a number. That is why Kubernetes is the best choice for production applications. Now we know our operating system, we know we're going to use Kubernetes for containerized applications. Now we need to choose a Kubernetes cluster to install. We have multiple options like the official kubeadm tool, or Rancher's Kubernetes engine called RKA, or OpenShift by Red Hat, or Micro K3S by Canonical. But the OpenShift or the official Kubernetes cluster requires so much CPU power and memory, and that is why we look into the lightweight flavors. One of them is K3S, and it is just a simplified Kubernetes, but it uses half memory than the official Kubernetes cluster, and it comes with just a less than 100 megabytes binary file. That is why K3S is one of the best choices for using Kubernetes on an ARM machine like Raspberry Pi. For the proposed system, you can find the details on the previous video in the hardware section. Basically, we need at least 2 Raspberry Pi to create a cluster because we need at least 1 master node and 1 worker node, and we need a couple more hardware to install the system and create the environment. If you want to learn how to install the Kubernetes cluster on Raspberry Pi, you can watch the previous video. After everything, I ended up buying 3 Raspberry Pis, with one of them has 2 GB and the others have 8 GB of memory. I connected them with an 8-port unmanaged switch and powered them with 12-port and 220 watt USB charger. And I also added a SSD to the master node, and I'm planning to create a NAS server with a couple more SSDs and creating my own self-hosted environment with email server, file storing and sharing server, video conference server, my own Git server on Kubernetes, and so many more. And that's it. Now I hope you understand why creating a Kubernetes cluster with Raspberry Pi is a better alternative for buying $100 of legacy servers. And thank you for listening.